We shall continue our discussion. I hope I don't take a full 40 minutes. Maybe in 20 to 25 minutes I would be able to complete whatever I want to discuss about this topic. Yeah, please remember, I was telling you about E1. Here E1 value is minus 2.18 into 10 to the power of minus 18 joule. You can convert this minus 2.18 into 10 to the power of minus 18 joule to electron volt. And if we express that energy in electron volt, you are going to get a value of minus 13.6 electron volt. And to do this conversion, you have to remember this: 1 electron volt is equal to 1.6 into 10 to the power of minus 19 joule. Okay. So usually we express energies of the electron in terms of electron volt. So therefore, in terms of electron volt, energy of the electron in the first allowed orbit, n is equal to 1, first allowed orbit of hydrogen atom is given by E1 minus 13.6 electron volt. Okay. If you want the expression for energy for hydrogen atom itself, let us say for second orbit or third orbit or fourth orbit, for any nth orbit. So using this expression En, in note 1 ನಲ್ಲಿ ಇದೆ ನೋಡಿ, note 1 ನಲ್ಲಿ En is equal to minus me power 4 divided by 8 epsilon h square n square ಅಂತಿದೆ. This me power 4 divided by 8 epsilon square h square ಇದೆಯಲ್ಲ, this whole thing is 13.6 ಆಗುತ್ತೆ. So that you can write equation 10. Equation 10 is En is equal to minus 13.6 electron volt divided by n square. So for any orbit in hydrogen atom whose principal quantum number is n, the energy is given by En is equal to minus 13.6 electron volt divided by n square, equation 10. Okay, please remember this equation 10 is applicable only for hydrogen atom, not for any atom else. Okay, ಬೇರೆ ಯಾವ ಅಟಮ್ಗೂ ಆಗೋದಿಲ್ಲ, ಯಾಕಂದ್ರೆ z is equal to 1 ಅಂತ ಹಾಕೊಂಡ್ಬಿಟ್ಟಿದ್ದೀವಿ, ಹಾಗಾಗಿ ಹೈಡ್ರೋಜನ್ ಅಟಮ್ ಮಾತ್ರ ಅಪ್ಲೈ ಆಗುತ್ತೆ. Okay, so next, so we shall try to find out one more simple expression, the expression for the wave number. Okay, so we are trying to find out one more expression, and that expression that we are deriving is the expression for the wave number. Please remember, according to third postulate, the last postulate of Bohr's theory, when an electron makes a transition from higher energy orbit to the lower energy orbit, then the difference in energy is emitted in the form of a photon. Okay, so is emitted in the form of a photon, and that energy of the photon h nu, ನಾನು ಮತ್ತೆ ಹಿಂದಕ್ಕೆ ಹೋಗೋದಿಲ್ಲ, ಹಾಗೆ ಹೇಳ್ತೀನಿ ನಾನು. Energy of the photon h nu is equal to ei minus ef, where ei is the energy of the electron in the initial orbit and ef is the energy of the electron in the final orbit. ಆ ಎರಡು ಎನರ್ಜಿ ಆರ್ಬಿಟ್ಸ್ ಗಳಲ್ಲಿ ಅಥವಾ ಎರಡು ಆರ್ಬಿಟ್ಸ್ ಗಳ ಎನರ್ಜಿನ ಸಬ್ಟ್ರಾಕ್ಟ್ ಮಾಡಿದ್ರೆ, ಡಿಫರೆನ್ಸ್ ತಗೊಂಡ್ರೆ, that difference ei minus ef must be equal to h nu. That is according to the last postulate of Bohr's theory. Okay, now if the electron is giving out radiation, so there is a photon has a frequency. If it has a frequency, definitely it has a wavelength. Okay, and that reciprocal of wavelength 1 by lambda is wavelength, and reciprocal of wavelength 1 by lambda is what we call it as wave number. Okay, here we are trying to find out an expression for wave number of the emitted photon. Okay, wave number is nothing but reciprocal of wavelength. Wavelength lambda ಏನು ಬರುತ್ತೋ ಅದನ್ನ 1 by lambda ಅಂತ reciprocal ತಗೊಂಡ್ರೆ ಅದನ್ನೇ wave number ಅಂತ ಕರಿತೀವಿ, and we are trying to derive the expression for the wave number. Okay, so it is very simple, ತುಂಬಾ ಸಿಂಪಲ್ ಆಗಿದೆ, ನೋಡ್ಕೊಂಡು ಹೋಗಿ ಫಾಲೋ ಮಾಡ್ತಾ ಹೋಗಿ. Let En1 and En2 be the energies of the electron in the orbits n1 and n2 respectively. I have expressed energies in terms of your principal quantum number n1. So when for an orbit whose principal quantum number is n1, the energy of the electron is en1. For an orbit whose principal quantum number is n2, the energy is en2. And we are assuming n2 is greater than n1. n2 is greater than n1 means electron is actually making a transition from n2 to n1. Electron initial ಆಗಿ n2 ಆರ್ಬಿಟ್ ಅಲ್ಲಿ ಇರುತ್ತೆ, ಆಮೇಲೆ n1 ಆರ್ಬಿಟ್ ಗೆ ಜಂಪ್ ಹೊಡೆಯುತ್ತೆ. ಅಥವಾ ಎಲೆಕ್ಟ್ರಾನ್ ಯಾವ ಆರ್ಬಿಟಲ್ ನಲ್ಲಿ ಇರುತ್ತೋ ಅಲ್ಲಿ ಎನರ್ಜಿ en2 ಇರುತ್ತೆ, ಆಮೇಲೆ ಅಲ್ಲಿಂದ en1 ಅಂತ ಕಡಿಮೆ ಎನರ್ಜಿ ಇರೋ ಆರ್ಬಿಟ್ ಗೆ ಎಲೆಕ್ಟ್ರಾನ್ ಟ್ರಾನ್ಸಿಷನ್ ಮಾಡುತ್ತೆ ಅಥವಾ ಜಂಪ್ ಹೊಡೆಯುತ್ತೆ. Okay, so then in that respective case, let nu be the frequency of the photon emitted. Okay, when the electron makes a transition from, when the electron jumps from orbit n2 to n1. Okay, this is a very simple explanation. Electron is making a transition from orbit N2 to N1, so therefore there is a photon, and as per Bohr's frequency condition, the energy of the photon h nu is equal to En2 minus En1. ಹೌದಾ, ಸರಿ ಇದೆಯಾ ಇದು ಎಕ್ಸ್ಪ್ರೆಷನ್? Do you agree? Correct ಇದೆಯಾ? h nu is equal to En2 minus En1 ಸರಿ ಇದೆಯಾ? ಫಾಲೋ ಮಾಡಿದ್ರೆ ಸರಿ ಇದೆ ಅಂತ? I want reply from your side. Follow ಮಾಡ್ತಾ ಇದ್ದೀರಾ?
Yes, sir.
Yes, sir.
Okay, so here I am using this expression 9. Expression 9 says n is equal to minus m z square e power 4 divided by 8 epsilon naught square h square by n square. Okay, if I substitute n1, then I am going to get en1. En1 is equal to minus m z square e power 4 divided by 8 epsilon naught square h square n1 square. If I use the same expression for n2, then I am going to get en2 is equal to minus m z square e power 4 divided by 8 epsilon naught square h square divided by n2 square. Okay, so I am using this expression 9 for both n1 and n2, so that I am going to get en2 and en1. Okay, and I am substituting in equation 11. Ayyo Shivni, tumba disturbance Mohana. Okay, mute ಮಾಡ್ಕೊಳ್ಳಿ. ಒಂದೊಂದ್ಸಲ ನಾನು ಇಲ್ಲಿ ಮ್ಯೂಟ್ ಮಾಡಬಹುದು, ಬಟ್ ಇಲ್ಲಿ ಮ್ಯೂಟ್ ಮಾಡ್ಕೊಳ್ಳೋಕೆ ಆಗಲ್ಲ ಒಂದೊಂದ್ಸಲ ನನಗೆ. Yes, so here if I substitute in equation 11, left side ಅಲ್ಲಿ h nu ಇದೆ, en2 ಜಾಗದಲ್ಲಿ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ, en1 ಕೂಡ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಎಲ್ಲ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ರೆ ಪ್ಲೀಸ್ ರಿಮೆಂಬರ್, ಸೊ en1 ಅಲ್ಲಿ ಪ್ಲಸ್ ಬರುತ್ತೆ, ಮೈನಸ್ ಇದೆ, ಮೈನಸ್ ಇಂಟು ಮೈನಸ್ ಪ್ಲಸ್ ಆಗುತ್ತೆ, en2 ಗೆ ಮೈನಸ್ ಆಗುತ್ತೆ, ಅಂಡ್ ಎಲ್ಲಾ ಟರ್ಮ್ಸ್ ಕಾಮನ್ ತಗೊಂಡಾದ್ಮೇಲೆ 1 divided by n1 square ಮತ್ತೆ 1 by n2 square ಕಾಮನ್ ಬರುತ್ತೆ. So I have escaped many steps here, and directly I have written, so h nu becomes equal to m z square e power 4 divided by 8 epsilon square h square 1 divided by n1 square minus 1 divided by n2 square. So this is equation 12. ಹೌದಾ? ಸೊ ಜಸ್ಟ್ 11ರಿಂದ equation 12ಕ್ಕೆ ಹೇಗೆ ಹೋಗಿದೀವಿ ಅಂತ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ ಆಮೇಲೆ ನೀವು ನೋಡ್ಕೊಳ್ಳಿ. ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ರೆ ಯು ಆರ್ ಗೋಯಿಂಗ್ ಟು ಗೆಟ್ ದಿಸ್. ಇದರಲ್ಲಿ ಮಾಡ್ದಲೇ ಇರುವಂತದ್ದು ಏನೇ ಬ್ರಹ್ಮಾಂಡ ಏನಿಲ್ಲ, ಇಟ್ಸ್ ವೆರಿ ಈಸಿ, ತುಂಬಾ ಸಿಂಪಲ್ ಆಗಿದೆ. ಓಕೆ, so you are going to get the expression for h as this way, equation 12, after substituting for en1 and en2. en1 ಅಂತಂದ್ರೆ ಎಲ್ಲೆಲ್ಲಿ n1 ಇದೆ, ಸಾರಿ ಎಲ್ಲೆಲ್ಲಿ n ಇದೆ ಅಲ್ಲೆಲ್ಲ n1 ಹಾಕೊಳ್ಳೋದು. en2 ಅಂತಂದ್ರೆ ಎಲ್ಲೆಲ್ಲಿ n ಇದೆ ಆ ಜಾಗದಲ್ಲೆಲ್ಲ n2 ಹಾಕೊಳ್ಳೋದು. Okay, now if lambda is the wavelength of the radiation, then frequency nu is equal to c by lambda. ಹೌದಾ? Velocity of light is equal to frequency into wavelength ಆಗುತ್ತೆ, so therefore frequency must be equal to c by lambda. And I have already told 1 by lambda is wave number. 1 by lambda is wave number, and wave number is denoted by nu bar. Okay, so therefore nu is also equal to c into nu bar. Nu is equal to c by lambda. This is equal to c. 1 by lambda is wave number. Symbol for wave number is nu bar, so therefore it is c into nu bar, where nu bar is equal to 1 by lambda is your wave number. So therefore I am going to substitute in equation 12. So I am going to get h into nu is c into nu bar m z square e power 4 divided by 8 epsilon square h square divided by 1 by n square minus 1 by n2 square ಆಗುತ್ತೆ. Okay, and then afterwards, so I am going to get nu bar. So nu bar is equal to hc, right side ಗೆ ಕಳಿಸ್ತೀನಿ. Nu bar is same as 1 by lambda. So therefore hc right side ಗೆ ಹೋದ್ರೆ m z square e power 4 divided by 8 epsilon square ಇದೆ, h square h ಸೇರಿ h cube ಆಗುತ್ತೆ. ಇಲ್ಲೊಂದು c ಇದೆ, c ಕೂಡ ಡಿನಾಮಿನೇಟರ್ ಬರುತ್ತೆ. So I am going to get 1 by n1 square minus 1 by n2 square, equation 13. Okay, so again we are going for the simple case of hydrogen atom. So if you go for the simple case of hydrogen atom, z is equal to 1. Okay, z is equal to 1. So therefore if I substitute z is equal to 1, so you are going to get nu bar is equal to 1 by lambda, that is equal to m e power 4 divided by 8 epsilon square h cube into c into 1 by n1 square minus 1 by n2 square. Okay, so therefore this term m e power 4 divided by 8 epsilon square h cube c ಎಲ್ಲಾದು ಕಾನ್ಸ್ಟೆಂಟ್ ಅಬ್ಸರ್ವ್ ಮಾಡಿ. m is mass of the electron constant, e is charge on the electron constant, epsilon naught permittivity of phase space constant, h is Planck's constant, c is velocity of light in constant. So therefore this entire term is a constant, This entire term we write it as R subscript H. Okay, this R subscript H is what we call it as Rydberg's constant for hydrogen atom. This whole term me power 4 divided by 8 epsilon square h cube by h cube into c is written as R. R means Rydberg's constant, H means for hydrogen atom. So it is Rydberg's constant for hydrogen atom. So therefore, if you substitute RH, you are going to get a nu bar is equal to 1 by lambda, and that is equal to RH into 1 by n1 square minus 1 by n2 square. That is equation 15, and this equation 15 is what we call it as Balmer's formula. Okay, follow ಮಾಡ್ತಾ ಇದ್ದೀರಾ?
Yes, sir.
Yes, sir.
Yes. Okay, ದಯವಿಟ್ಟು ಸ್ವಲ್ಪ ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ಗೊತ್ತಾಗ್ಲಿಲ್ಲ ಅಂತಂದ್ರೆ ನೀವು ಒಂದ್ಸಲ ಮಾಡಿ. ನಾನು ಇವತ್ತು ಆಮೇಲೆ ಸ್ವಲ್ಪ ಹೊತ್ತು ಆದ್ಮೇಲೆ ನಾನು ನಿಮಗೆ ನೋಟ್ಸ್ ಎಲ್ಲ ಕಳಿಸ್ತೀನಿ. ನಾನು ನಿಮಗೆ ಒಂಚೂರು ಕರೆಕ್ಷನ್ ಮಾಡಿ ಮತ್ತೆ ಸ್ವಲ್ಪ ಫೋಟೋ ಮತ್ತೆ ರೀಫೋಟೋ ತೆಗೆದುಬಿಟ್ಟು ಮತ್ತೆ ನಾನು ನಿಮಗೆ ಕಳಿಸ್ತೀನಿ. ದಯವಿಟ್ಟು ಒಂಚೂರು ವರ್ಕೌಟ್ ಮಾಡಿ. ಮಧ್ಯದಲ್ಲಿ ಕೆಲವೊಂದು ಸ್ಟೆಪ್ ನಾನೇ ಬೇಕು ಅಂತ ಅವಾಯ್ಡ್ ಮಾಡಿದ್ದೀನಿ. ಓಕೆ ವರ್ಕೌಟ್ ಮಾಡಿ ದಯವಿಟ್ಟು. ಓಕೆ, ಸೊ ದಿಸ್ ಈಕ್ವೇಶನ್ 15 nu bar is equal to 1 by lambda is equal to RH into 1 by n1 square minus 1 by n2 square is called the Balmer's formula, where RH is a constant and this constant is what we call as Rydberg's constant, and this is actually constant only for hydrogen atom. It is not for any other atom. ಬೇರೆ ಯಾವ atomಗೂ ಆಗಲ್ಲ, ಇದು ಬರೀ hydrogen atom ಮಾತ್ರ ಆಗುತ್ತೆ. So therefore for hydrogen atom this is Rydberg's constant for hydrogen atom. Okay, in fact you can calculate Rydberg's constant value. I have already written RH is equal to m e power 4 divided by 8 epsilon square h cube into c. So m is 9.1 into 10 to the power of minus 31. E is 1.6 into 10 to the power of minus 19 to the power of 4 whole to the power of 4 divided by 8 into epsilon naught. So permittivity of free space 8.852 into 10 to the power of minus 12 whole cube. H is Planck's constant 6.62 into 10 to the power of minus 34 whole cube. So divided by into c there 3 into 10 to the power of 8 ಇದೆ. ಸಾರಿ, ಇಲ್ಲಿ epsilon naught square ಇರಬೇಕಿತ್ತು, ಇಲ್ಲಿ ಕ್ಯೂಬ್ ಅಂತ ಹಾಕಿದ್ದೀನಿ. ಅಗೇನ್ ಇದೆಲ್ಲ ಕರೆಕ್ಷನ್ ಮಾಡಿ ಕಳಿಸ್ತೀನಿ. If you do this calculation, if you do this entire calculation, you are going to get a value of Rydberg constant RH that is equal to 1.091 into 10 to the power of 7 per meter. The value of Rydberg's constant as per Bohr's theory, this is they have calculated using Bohr's theory. So it is found to be equal to 1.091 into 10 to the power of 7 per meter. And the thing is, this calculated value of Rydberg's constant 1.09 into 10 to the power of 7 per meter, okay, actually matches very well with the experimental value. One can calculate Rydberg's constant experimentally also. One can find out Rydberg's constant experimentally also. And whatever that experimental value that we have found out, that value and this value, theoretically calculated value according to Bohr's theory, they are matching very well. Okay, in fact this is one of the experimental support for Bohr's theory. Whatever the value of Rydberg's constant that we have calculated from Bohr's theory matches very well with the experimental value. Okay, this is one of the experimental support to Bohr's theory. Okay, now using this expression 15, please remember this expression 15. So nu bar is equal to 1 by lambda into RH into 1 by n1 square minus 1 by n2 square. I can keep on changing the values of n1 and n2. ಒಂದು ಎರಡು ಮಾತ್ರ ಹೇಳ್ತೀನಿ ನಾನು, ಉಳಿದಿದ್ದು ನಿಮಗೆ ಗೊತ್ತಾಗುತ್ತೆ ಅಂತ ಅನ್ಕೋತೀನಿ. ಅಥವಾ ಅಟ್ಲೀಸ್ಟ್ ನೀವೇ ಹೇಳಿ. What I am going to get if I substitute n1 is equal to 1 and n2 is equal to 2, 3, 4, 5. I repeat, in equation 15, I am going to use equation 15. I am going to restrict the values of n1 and n2 such that n1 I am going to choose 1. n1 ಅಂತ ಇದೆಲ್ಲ ಆ ಜಾಗದಲ್ಲಿ 1 ಹಾಕೋತೀನಿ. n2 ಮಾತ್ರ I can substitute 2 or 3 or 4 or 5 or 6 or etc. So then what I am going to get? If I substitute the value of n1 is equal to 1 and n2 is equal to 2, 3, 4, 5, what series I am going to get? N sigute? That's what I have written here. If you substitute the value of n1 is equal to 1 and n2 is equal to 2, 3, 4, etc., then it is possible to calculate the wavelengths of members. Yes, that is what we call it as a Lyman series. Substituting n1 is equal to 1 and n2 is equal to 2, 3, 4, 5, etc., gives wavelengths of Lyman series, wavelength of a wave number, frequency, whatever you want to call. It is wavelengths of Lyman series. Okay, the very first series that we observed in the case of hydrogen atom is what we call it as Lyman series. In the case of Lyman series, N1 is equal to 1 and N2 is equal to 2, 3, 4, 5. That means if the electron is making transition from 2 to 1, or if the electron is making a transition from 3 to 1, or if electron is making a transition from 4 to 1, or if in general, if an electron is making transition from any higher energy orbit to n is equal to 1, n is equal to 1 first energy orbit, okay, then it actually leads to Lyman series lines. The lines are called Lyman series lines, and these Lyman series lines, they come under ultraviolet region of the electromagnetic spectrum. So therefore, for Lyman series, you can write 1 by lambda is equal to RH into 1 by 1 square divided by 1 by n square, where n can be substituted 2, 3, 4, 5, etc., etc. So if you substitute 2 is equal to, sorry, n is equal to 2, that gives wavelength of first member of Lyman series. If you substitute n is equal to 2, sorry, 3 here, you are going to get wavelength of second member of the Lyman series. If you substitute n is equal to 4 here in this expression, you are going to get the wavelength of the third member of the Lyman series. Follow ಮಾಡ್ತಾ ಇದ್ದೀರಾ?
Yes, sir.
Yeah, these are all basic information. ಎಲ್ಲ ನೀವು PUC ಓದಿರ್ತೀನಿ ಹೇಳ್ತಾ ಇರೋದು, ಯಾವುದು ಕೂಡ ನಾನು ಸೊ ಯಾವುದು ಹಳೆಯದು ಕೂಡ ನಾನು ಏನು ಹೇಳ್ತಾ ಇಲ್ಲ. ಸೊ therefore ಸರಿ ಬ್ರೋ, ಯಾರಿಗಪ್ಪ ಮೆಸೇಜ್ ಮಾಡ್ತಿದ್ಯಾ ವಿವೇಕ? ನೀನ್ ಮಾಡೋ ಮೆಸೇಜ್ಗಳು ಎಲ್ಲರಿಗೂ ಕಾಣುತ್ತೆ. ಯಾರಿಗಪ್ಪ ಸರಿ ಬ್ರೋ ಅಂತ ಕಳಿಸಿದ್ಯಾ? ನನಗೆ ಕಳಿಸಿದ್ಯಾ ಸರಿ ಅಂತ? ವಿವೇಕ್, so if we substitute N1 is equal to 1 or N2 is equal to 2, 3, 4, we end up with Lyman series lines of hydrogen atom. The very first series of hydrogen atom is called the Lyman series, and Lyman series lines are given by 1 by lambda is equal to RH into 1 by 1 square minus 1 by n square, where n values are 2, 3, 4, etc., etc., etc. And these Lyman series lines, they come under so ultraviolet region of the electromagnetic spectrum, and we have several members. So 2 to 1, n is equal to 2 ಹಾಕೊಳ್ಳಿ, 2 to 1 ಆಗುತ್ತೆ. 2 to 1 transition, first member of Lyman series. n is equal to 3 ಹಾಕೊಂಡ್ರೆ 3 to 1. 3 to 1 makes so second member of the Lyman series. So 4 to 1, third member of the Lyman series. Fourth member of the Lyman series, and so on. Okay? And if you substitute n is equal to infinity, can you say what you are going to get? Can somebody say? N is equal to infinity 2, 3, 4 ಅಂತಂದ್ರೆ n is equal to infinity is also possible. What I am going to get is if I substitute n is equal to infinity here in this expression.
1.
Can somebody say what I am going to get if I substitute n is equal to infinity? If I substitute n is equal to infinity, 1 by infinity is 1 by infinity square, 1 by infinity is 0 ಇದು ಹೊರಟೋಗುತ್ತೆ. So therefore 1 by lambda is equal to RH into 1 by 1 ಆಗುತ್ತೆ, or 1 by lambda is equal to RH, or lambda is equal to 1 by RH ಆಗುತ್ತೆ. That is the last member of the Lyman series. The last member of the Lyman series is what we call it as series limit of Lyman series. I repeat, 2 to 1 gives the first member, 3 to 1 gives the second member, 4 to 1 gives the third member, 5 to 1 gives the fourth member, etc., etc., etc. Infinity to 1 gives the last member. The last member of the Lyman series is called series limit of Lyman series. Okay? Yeah, similarly, ನೀವು ಒಂದು ಪ್ರಶ್ನೆ ಕೇಳಬಹುದಿತ್ತು ಅಥವಾ ಕೇಳಬಹುದು ಇದು ಕೂಡ, ಯಾಕೆ ಸರ್ ನೀವು n1 ಗೆ 1 ಹಾಕಿದ್ರೆ 2 ಹಾಕಿದ್ರೆ ಏನಾಗುತ್ತೆ? If I substitute ಇಲ್ಲಿ 1 square ಅಂತಿದೆ ನೋಡಿ, ಈ ಜಾಗದಲ್ಲಿ 2 square ಹಾಕೋಬಹುದು. ಅಂದ್ರೆ if I substitute n1 is equal to 2 and n2 is equal to 3, 4, 5, etc., 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 then we are going to get the second series. The second series of hydrogen atom is what we call as Bohr series. The lines are called Bohr series lines, and these Bohr series lines, they come under visible region. For example, 3 to 2, the first member of the Bohr series, 4 to 2, the second member of the Bohr series, 5 to 2, the third member of the Bohr series, and so on. And infinity to 2, the last member of the Bohr series. The last member of the Bohr series is also called as series limit of Bohr series. Okay? So you can actually continue in this fashion. n1 is equal to 3 ಹಾಕಿ, ಆವಾಗ n1 is equal to 3 ಹಾಕಿದ್ರೆ n2 is equal to, I am extremely sorry, ಮತ್ತೆ ಇಲ್ಲಿ 3 ಬಂದಿದೆ, 4 ಇಂದ ಶುರುವಾಗಬೇಕು. n1 is equal to 3 ಆದರೆ n2 ಎಲ್ಲ the next value ಇಂದ ಶುರು ಆಗಬೇಕು. n1 is equal to 3 and n2 is equal to 3 ಎಲ್ಲ ಇದು 4 5 6 etc. Then you are going to get Paschen series. You substitute n1 is equal to 4 and n2 is equal to ತುಂಬಾ ಮಿಸ್ಟೇಕ್ ಆಗಿದೆ ಇಲ್ಲಿ 5 6 7 8 etc. Then you are going to get bracket series. If n1 is equal to 5 and n2 is equal to 6 7 8 9 etc. Then you are going to get find the series. Okay, I think you might have heard of this. ನಿಮಗೆ ಆಲ್ರೆಡಿ ಗೊತ್ತಿದೆ ಇದು. The very first series of hydrogen atom is called a Lyman series, and these Lyman series lines come under ultraviolet region. The second series of hydrogen atom is called the Bohr series, and these Bohr series lines come under visible region. The third series is called Paschen series. The fourth series is called the bracket series. The fifth series is called the Finder series. And these lines, actually, these 5 series, actually, they are 5 important series of your hydrogen atom. Okay. Anyhow, so I would like to give one conclusion. So the conclusion is, so as per Bohr's theory, okay, and remember this Bohr's theory is based on the quantum theory, Planck's quantum theory. This Bohr's theory is completely based on quantum theory. So therefore we can say that either Bohr's theory or quantum theory successfully explain the stability of atoms and the atomic spectrum of hydrogen atom. Okay, so far what we have discussed is only the spectrum of hydrogen atom. So we shall not bother about the spectra of other atoms. Actually, Bohr's theory fails to explain the spectrum of other atoms. Okay, but anyhow, if we forget that one, at least we can say that Bohr's theory successfully explains the spectrum of hydrogen atom. ಬೇರೆ ಸ್ಪೆಕ್ಟ್ರಮ್ ನ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಕ್ ಆಗಿದ್ರು ಬೋರ್ಸ್ ಥಿಯರಿ ಕೆಲ ಸ್ಪೆಕ್ಟ್ರಮ್ ಆಫ್ ಹೈಡ್ರೋಜನ್ ಆಟಮ್ ನ ತುಂಬಾ ನೀಟಾಗಿ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡುತ್ತೆ. ಸೊ ಕನ್ಕ್ಲೂಷನ್, Bohr's theory based on the quantum theory successfully explains so both the experimental facts, the stability of atoms and the spectrum of hydrogen atom. Okay, whereas our classical theory, the first theory, could not explain so the stability of atoms and the spectra of atoms, hydrogen atom at least, whereas our quantum theory successfully explains so stability of atoms and spectrum of hydrogen atom. Okay.